was overwhelming. Thanks a lot for coming to this probably inaugural tech show and tell for Burlington. I'm Zev Averbach, and I'm like a baby technologist, really, and but enthusiast. And I met almost everyone presenting tonight on Twitter. I'm pretty sure, initially, anyway. So that's pretty much it. We're just gonna roll with it. 5-minute lightning talks, and let me just introduce our first talker. So Uwe Heiss is a chemist by training and a serial parallel entrepreneur. He's prolifically active in the quantified self movement, and he's created the first honest placebo product in the market. You can use this.
Yes. Can you hear me fine, like this? Good, great. So I trust.
Would you like some light?
Light? I'm fine. Wow. Well, I don't know. If you like it, fine. So, okay. So I just gave this presentation in Silicon Valley at the Quantified Self at Singularity University, and Bayer Pharmaceuticals was in the room, and they said if I worked for them, they would fire me right away. So we have a problem. Over the last 30 years, placebos have caught up with prescription pharmaceuticals. The difference for pain treatment used to be about 30% between placebo and the active drug. And now when it comes to FDA-reviewed trials, it's on average only 9%. So it's getting harder and harder for pharmaceuticals to receive FDA approval. And why could that be? Well, this effect only happens in the US. And over the last 20 years, we started here with direct-to-consumer advertising by pharmaceutical companies. And people's trust in powerful brands has grown over time. And also, trials have become more expensive. That's a long story. But it all leads to a more powerful placebo effect. And this is actually wonderful, because people actually benefit from the effect. So, and you saw on the previous slide how placebos are catching up. Drugs are not getting weaker. Placebos are getting stronger. So I say there's a place for placebos in conventional healthcare, and it has actually been shown at Harvard, at the Center for Placebo Studies, that even if people take a placebo knowingly, it still works. Right? So this opens up new options for us. So, as I say, right, there's a place for placebos in conventional care. And what really makes up a successful placebo is the design, the branding, and the price. And so wouldn't it be great if such a product already existed? And there's good news. I released Placebo Relief this year. With all the hallmarks of a successful placebo. And it's the first honest placebo in the world. Now, what's the role of a patient, right? I mean, we all have been conditioned to respond positively to pill-taking experiences. So taking the pill is a trigger. It can affect the subliminal mind with us believing in it or knowing or not knowing what's going on. But there's a hurdle. And the hurdle is, it's a rational filter, right? If I think it can't work for me, well, I won't take it, so I'll never have a chance to try it out, right? So in the future, doctors can help with that. They can say something like this to a patient. Even if you're skeptical, knowingly taking a placebo can trigger a positive conditioned response by your body. Do you want to try a SIBO, right? And that might be like the framing you need to get people to try it. So the role of the quantified self have been active since we started in 2011. And we quantify things that we do, like steps and heart rate, what have you. So the community can help by basically visualizing the placebo effect, right? And then by that, reinforcing it. And also there's a question, does self-tracking itself produce a placebo effect? I make apps called Track and Share and Bowel Mover Pro and Autism Tracker. People track what they're doing every day, and they look at correlations and patterns and trends, and that might give people enough control to actually get better and to activate something in their own mind and body. So we need a quantified placebo treatment. That's my conclusion, right? Wouldn't it be great to combine both the placebo with a tracking app? And so, wouldn't it be great if that already existed? So here it is, right? We made SIBO the quantified treatment solution. It's an app that comes together with a pill. So you track before and after taking the pill, if your migraine or your sadness has improved, and we just play this back to you, and you can see if you benefit from placebos or not, which is something that would be actually meaningful for any prescription drug that you are taking to systematically measure if it's actually working for an individual patient, also called precision medicine. The process, it's very simple. Baseline, you take the pill. You can also take it virtually. You don't have to take the real pill. And then you have a follow-up reminded by the app, and you see in a graph and in a history then how you did on the placebo. So there are 4 use cases. First, you can try to use it to enhance standard treatment. That's what we did at Harvard with IBS. You just add a placebo and see what happens, right? No harm done. You don't change anything else. Another step is this one, right? Let's go back to the first do no harm principle, because we are severely overprescribed as a society. So why not start with a placebo for a couple of weeks, and then if that's not good enough, you can still step it up to a pharmaceutical and biochemical drug. Another way is to facilitate transitions. Opioid dependency is a huge problem in the US. So you could add a placebo and then take both for a while and then take the opioid away and see if the placebo itself carries enough meaning and kind of feeds the habit that you can finally go without any of those. Now we can also learn to transform pain. I'm an active meditator, and pain might appear like something like this. It's overwhelming, it's horrible, but then if you really zoom in, you find that pain is a lot more than just this glob of stuff. It's actually, physical pain, suffering, function, and a lot more. So by, consciously taking a placebo, you might be able to kind of detangle pain a little bit by becoming more aware of what's going on. Right? So benefits are clear, and what is really, benefits, okay, prescription drugs are only slightly better than placebo when it comes to symptom relief. Active drugs have risk of, short-term, long-term side effects, and the placebo is a way really to increase safety, precision, and choice and timing in care. And so the real challenge that remains is to basically find ways to preserve the full placebo effect with an honest placebo. And that's what I'm working on right now, teasing that out. That's the main challenge. Okay, that's it.
Nice.
Thank you. Wow, it was the wrong presentation.
Really?
Yeah.
Cool. All right. Oh, yeah, do you want to sit up? Sorry. All right, so Andy Reagan is a PhD candidate at UVM in applied math and complex systems, studying social dynamics and happiness.
Alright, so I'm going to tell you guys about Quokka Labs, powered by the Hedonimeter. So I think that big data and social networks are really changing the way that we gain information, the way that we interact with each other, and they're also changing the way that we're able to gain information and understand how we interact. So through this, we can study things that weren't possible before. And there's a lot of opportunity to understand how people behave and to study these things. So we've developed at UVM is the Hedonimeter technology, and so what this allows us to do is to feed in different data sources. So here you can see Twitter and looking at song lyrics. We're able to study those using the Hedonimeter like a physical instrument by looking at the words that are contained in those, and we're able to generate different analysis of that social data. So here you see an example of a time series of happiness on Twitter. We can dive in and look at the words about why things are changing, and we can look at how people interact together through their social networks. So this is a network of Twitter users connected by retweets. Right? So if we dive in and look at the Hedonimeter, this is the Hedonimeter website, hedonimeter.org, over the past 18 months. And so you can see that we see Valentine's Day is a happy day, right? And we're able to detect large-scale social phenomenon by just looking at the words used on Twitter. And we see that the happiness and the sentiment goes down sometimes when you would expect it to for these events, and we also find the collective happiness. Right, we can look at this sentiment over time. So here's looking at the United States over the past 30 days. So Vermont ranked in number 3. Usually we're number 1, so I apologize. You guys need to tweet it out a little more. Right? And we can go check after the talk. So who are we? So this was developed by Chris Danforth, Peter Dodds, and myself. Chris and Peter work at UVM. They're both professors in mathematics with the Complex Systems Center. And as Zev said, I'm a PhD candidate, probably graduating next year. So this technology was developed with our whole research team at Computational Story Lab. This is a subset of people that have been involved in particular Mark, who's here, is not up here. But and so this our research group is part of the Vermont Complex Systems Center. Over the past 6 years, we've been really productive. We've published 38 papers, and our work has been covered in a lot of different places. We developed the hydrometer over time. So in 2006, the lab was founded, and we were inspired by wefeelfine.org, which is this, it's an analysis of blogs that was done by Seth Kamvar and Jonathan Harris. In 2008, we started collecting tweets. Twitter came around, and we opened the spigot, and we started getting the tweets flowing in. And by 2011, we were analyzing tweets using the hedonimeter technology. We originally launched the website, hedonimeter.org, in 2013. Since revamped it to our latest version, and in 2015, we incorporated a company to commercialize this technology called Quokka Labs. There are a lot of potential use cases for Quokka Labs and how we can take our sentiment analysis engine and apply it to different products and different markets. So at the top, you see a few stocks, right? So financial investment firms are really interested in how people are feeling to be able to predict stock performance. So we can provide, we could build a product around analyzing the words around stocks. We also can analyze the success of marketing campaigns. So here you see Coke versus Pepsi. Coke launches a marketing campaign, and they probably want to know, right, how are people talking about this in mass? You know, can't just go look at a few tweets. We want to take all the tweets and look at the words contained in them. As well, we can look at how people are talking about politics. So we can look at over space, you know, how stories are evolving around issues. And we're also building, we can also build a product around detecting events and sifting out the big stories from social networks as they unfold, right? So, all right, so that's all I have, and here's a quokka if you haven't seen one before.
Is a computer science undergrad at UVM. He's interested in security and attended DEF CON this year, which is directly related to what he's going to present.
Thanks, Zev.
Yeah.
So I've got a lot of moving parts here, so I'll try to be quick, and we'll count this against my time. So I went to DEF CON this year, which is a big security conference in Las Vegas, and somebody handed me this like IoT security camera, and they said, go. So I had a swing at it, and let's see what we can do.
You're running Linux?
Yeah. Okay, so yeah. Alrighty, so this will be anatomy of an IoT security fail. So I was going to wear my NetBSD shirt, because I don't know if anyone remembers, but back in the early 2000s, the NetBSD people really pioneered the whole idea of like attaching useless things to the internet. So that was like the original IoT toaster there. Oh no, I lost my stream. Seems to be.
Is it frozen?
Yeah. All right. Yeah. So this was sort of the original like uselessly connected to the internet thing, and since then people have gotten nuts. So this is just like a pile of things I found on the internet. So here's a camera I'm going to talk about. This was a toilet, I guess, created by Microsoft called the MSN iLoo. That never came to market. If you followed the press this summer, you may have heard about the Chrysler car hack. There's an internet-connected gun, power plants, light bulbs, doorknobs. Doorknobs is a bad idea. I don't know why people like to do that. But anyway, so I decided to take a whack at this guy here. Yeah, okay, so anyway, what this guy is, it's basically an internet-connected surveillance camera, right? So you buy this thing at Best Buy, it's like $50. You know, you put it in your living room, and you know, you can look at your pet when you're on vacation or whatever. Yeah, dogs on the internet. So anyway, I hope everyone can kind of see this okay because it's not super big. But basically, it's got, you know how like your home router has like an admin interface kind of thing? So it's got the same thing. You go in there and you can like watch video. Here's sort of like, that's looking into my kitchen, you know, that's all good. So the first thing I did was I got my hands on the device. I logged in legitimately, right? Made a password. And I'm kind of hunting around. And you know how when you like hover your mouse over a link, it shows you like the URL of the link? So I hover over there and I see this. And I'm like, no way. If you can't read that in the back, that's like, so it's a URL, you know, the video page, and then it says login equals true. And I'm like, you've got to be kidding me. So I logged out and I typed that exact thing back in, and I was in. That was it. So now I'm the administrator, right? And so of course the first thing I did was I went straight for the firmware update
Sorry,
page.
there's one more of those. It's
Okay.
just going to happen.
Yeah, so I go straight for the firmware update page, right? Because I'm like, okay, this is going to be interesting. So I go to the firmware update page, and I take a packet capture. So I don't know if anyone's ever used Wireshark, but basically it allows you to capture like packets that are going back and forth on a network. So I open up Wireshark, I go to the admin firmware page, and this is what I see. You see a GET request for the firmware page, right? And then you see a DNS request for SamsungSmartCam.com, and then another GET request for firmware.xml. And it's using unencrypted, just regular HTTP, no encryption at all. So I'm like, cool. So the next thing I do is I go to the network settings page, and you see here you can change the DNS server, right? So I decide to change the DNS server to a DNS server that I control, right? And basically I do a DNS spoofing. I download, I'm basically mirroring Samsung's like firmware page on my own web server, and I'm pointing the camera at it, right? So now when you go to the firmware update page, this is going to be hard to see, but it says current version of the firmware 2.12, latest version 2.13. That's my version. And so I thought that actually, at this point, I have to modify the firmware, right? And I'm like, this is going to be hard. It's going to be a pile of like an assembly code. I don't know what to do with it. So I download it and I unpack it and I look at it, and it's not at all. It's actually like a Linux disk image. It's just a bunch of files that you can edit, right? So I don't know. So if you're familiar, if you've ever done any like sysadmin work, you know that on a Linux computer, if it uses like the old school init system, the first thing it does is it goes and it starts running some shell scripts. So I just start editing those shell scripts and adding stuff to them. So what I did was I added a little backdoor command, saved it, packed the whole thing back up, and you know, now we're seeing this, right? Current version 2.12, current, you know, latest version, my evil version, and I'm like, okay, I hope this works. And I click update firmware, and the little light turned blue, and I was like, yes, I got it, right? So it starts updating. It takes about 10 minutes. It reboots, and so then I use a program called Netcat, which is sort of like Telnet, and I kind of just netcat into the thing, and I get a shell. And it's running as root, so yep. That usually gets applause at security conferences. Yeah, so this is where I wanted to go do the live thing. Here, so at this point, the camera is it's basically a Raspberry Pi with a camera on it now. So I have root. I pretty much own the machine. So at this point, the possibilities are endless, right? You know, I thought about like maybe installing WordPress on it or something, you know, just to screw around. But I didn't really want to brick it, because if you screw it up, you can break things. So it's kind of a bummer that I didn't get to show you more of the hands-on stuff. I was going to have someone like change the password, and then I was going to
Did you
find
tell
out
did
where
you
said
tell
it.
Samsung?
Yeah, so yeah, I didn't think I'd have time to talk about that.
Just real quick.
Yeah, so when I found this, I tried to notify Samsung, and unfortunately they weren't very helpful. It's been months. They haven't updated the firmware, and they haven't. I've talked to a few people who were helpful, but I think they were ultimately too far down the ladder. So this vulnerability is still out there, but I'm sort of making it public because it's been a while. Yeah, so if you have a smart cam like this, what you need to do to protect yourself is keep this thing away from untrusted networks, basically. This attack can be done completely remotely. So basically, like if you've got this thing in your house and I can connect to your Wi-Fi, then I own your camera. So be careful about that. If you've got it on like a business network, you might want to think about VLANs, that kind of thing. So yeah. That's all I got. Yep.
All right. So there's pizza over here if you want to like quietly wander over, and beer and seltzer. Right. Tristan Davies is a futurist who uses radical clarity to create unique visions of metric analysis in post-zombie invasion societies. Also, he's the lead front-end engineer at Faraday. Do you need this? Or?
Yep. There it is.
Sweet.
Amazing.
Thanks.
Okay, so I'm going to talk for 5 minutes about WebTorrent. WebTorrent is a JavaScript module that lets you use BitTorrent on the web. If you thought JavaScript hadn't already gone too far, it now has. Okay? So, what is BitTorrent? BitTorrent, a lot like the background here, is a amalgamation of lots of nodes that are talking to each other. So with HTTP, you've got this network protocol where you say, hey server, can I get this cute cat picture? And it's like, yeah, I totally have this cat picture. Or sometimes you're actually talking to the NSA and it's like, hey, here's Stuxnet. And you're like, oh, my nuclear reactors. Which kind of illustrates the problem with HTTP. And then there's BitTorrent, where you say, hey, I want this cat picture, and then you get the cat picture and you share it with everybody else, and then everybody has the cat picture, and if the server goes down, the cat picture is still available for everybody. It's like communism, but for networking, okay? So, example of using this. You might not be able to read the code from here, but basically you get your WebTorrent library, you say, I want you to download this torrent or this magnet link, and then I want you to stick that in the body of the page. What does that look like? You get a couple peers, and then there's like a movie I didn't even notice about. Blender Foundation made it, probably about like dragons and mountains and stuff, but that's all you do. Take a torrent link, stick it in the body, and then you can watch movies. It also works with pictures, music, content, whatever you want, right? So why? Why would you want to do this thing? A lot of reasons. BitTorrent is very censorship resistant in most cases, so the Stuxnet thing, not going to happen, but also if, China decides that your slideshow is really lame and they want to block it, it doesn't matter because it's served over BitTorrent. It's really, really fast, scales infinitely, and is geographically distributed, so it's a peer-to-peer system. If you're in Australia and I'm in the United States and there's another peer in Australia, you can download from them. It'll be way faster. You don't have to go halfway around the world or 3/4 or whatever that is, and it's secure. You never ask for content and then get something else because of magic and cryptography and stuff like that. What can it be used for? Lots of things. Glad you asked. You can do a pretty simple file transfer. Again, you may not be able to read this, but this is just a code snippet, couple of lines where it makes a web page and you can drag some files from your desktop onto it, and then it'll just give you a link which you can share with other people, and they can download the content, but it never actually goes off. Like, you're not sticking it on S3 or a web hosting site. It just transfers directly from your computer to theirs, and if you send it to lots of people, it shares, they'll be sharing it with the other people you shared it with, and then if you leave, they'll still have copies of it. It's pretty great. And then you can extend the BitTorrent protocol in this. So this is a little chat room that turns that video about White Mountains and stuff into a chat room where you can talk to all the other people downloading it. I don't know why you'd want to do that, but the possibilities are endless. You can make your own peer-to-peer YouTube clone. I did not make this because it's relatively complicated, but if you go to like fastcast.co.nz, there are people with a YouTube clone. It runs all over BitTorrent, and they don't have to pay very much in bandwidth bills, despite the fact that all their videos are 4K for some reason, because everyone who's watching a movie is also uploading it to everybody else who's watching a movie. You can make your own peer-to-peer web. There are like lots and lots of people doing this, where they're making a new web using BitTorrent as a protocol. Basically, everybody like uploads their own public key, and there's this crazy system of like sending updates to people, and no one can ever censor anything, and no one can ever snoop on anything. It's pretty magical, but also really hard to do, which is why I did not make it for the purpose of this slideshow. You can make a slideshow that's entirely hosted on BitTorrent, which is what I did. And if I take down this server, it'll still run because it gets the next slide as it goes over BitTorrent. So that's pretty awesome. Not even the NSA can take down this slideshow. They actually totally could. But only because they have hammers. So yeah, infinite possibilities, use WebTorrent, make cool stuff. Thanks.
Can you guys hear in back? Okay, even when the machine's going? Not so much? Okay. All right. Bradley Holt is a developer advocate with IBM Cloud Data Services. He served on the BTV Ignite Advisory Committee and the board of VCAM, and is the co-captain of our local Code for America brigade, Code for BTV.
Thanks.
Hey, so work for a small little company called IBM. I work in a group called Cloud Data Services, and what we do is provide a whole bunch of data services in the cloud. All sorts of stuff based on open source projects like CouchDB, Apache Spark, stuff like that. So stuff for storing data, analyzing data, all that fun stuff. So I'm a developer advocate, and basically what I do is two things. I help explain to people what it is we do and what we have to offer. So I help talk to other developers and help them understand what our products can do. But it's also just as much bringing internal feedback to help us improve our products and kind of talk to developers and learn what would work better for them. So as part of what I do is create sample apps. So sample apps that people can install and try out and build on top of. One of the problems, though, we had is that we had no way of knowing if anybody was actually using any of these sample apps. So I created a deployment tracker that we could instrument into all of our sample apps that would ping a service and let us know whenever something got deployed. So I started this. A colleague of mine in the Bluemix team joined me and started working on it. A few other people have worked on it since then. But basically, we've got all these events that we're capturing, and we can record, we can analyze and drill down and see by month, for example, how many deployments there are. So I've obfuscated this, so I can't show you the actual numbers, but you get the basic idea. We created these deployment badges we can embed in our READMEs. These are all scalable vector graphics, dynamically generated, so you can see the total count of deployments for a particular repo. You can also do these deploy to Bluemix buttons. They existed before, but they didn't have a deployment count on them, so we created a version that has a deployment count, so you can throw this on your README or your tutorial or whatever. Someone can click that and go ahead and deploy the app. Bluemix, by the way, is our platform as a service, so it's where you can go deploy apps to and run them. And of course, this is all open source. Pretty much everything we do, we open source. So it's not much that isn't. I don't think there's anything I've worked on that isn't open source. So this is all on GitHub. It's called CF Deployment Tracker Service. CF is Cloud Foundry. So Bluemix is based on Cloud Foundry, which is open source. So this is so if you're doing anything on Cloud Foundry, you can use this. You're welcome to use it yourself. So we roll this up. We look at it in different ways. Here's a chart we look at to see trends over month by month. So we can see how many people are deploying sample apps this month. We can see how many new users have shown up. We can drill down and see week by week if we want. Really any level of time we want to look at. Here's one where we look at different repositories, so we can see if we're actually, as developer advocates, if we're actually rolling out new repos. You can see this last month here, we didn't create anything new, so we got to get on that. And then we can also tie this into to conversion, so we can actually cross-reference this data to see if people have actually bought anything from us, because at the end of the day, we want people to buy from us. So we can actually see like what demos are most converting, what services they're using, like are they using Cloudant, which is our database as a service, for example, that sort of thing. And then all the repos that we have this in, all the sample apps we put this in, we throw a privacy notice in just to make it really clear what we're doing. We want to make sure that we're upfront about that. And we provide instructions for how people can disable it if they want. So this is all built using all of our own services. It runs in Linux itself, and it actually tracks its own deployments. So when I deploy the deployment tracker, it actually pings the deployment tracker to track if there was a deployment of the deployment tracker. So that's fun. And uses cloud to store the data. And we built this very iteratively. The first version of this I built in like 2 days, 2 or 3 days, and then we've iterated on it since then. Yeah, I think that's all I got.
Still okay in the back, or? Yeah? A little louder. Okay. Nice. Okay, so Julie Lerman has been coding for almost 30 years and is a longtime Microsoft MVP. She loves helping developers all over the world learn to design software more effectively. She's also kind of the godmother of the coding meetup scene. Including
well, at least they didn't say grandmother.
including the umbrella meetup organization this is under tonight, Vermont Coder Connection. So, do you
Oh, I'm a loudspeaker. Okay. I'm quite loud. I can plug the HDMI right in if it's going to just work.
Yeah, it should work.
I have this too.
Where'd it go?
Oh, here it is. So you heard him say that Microsoft Word. I just want you to know, this is my first ever MacBook. I finally told Zev that my presentation was going to be me spending 5 minutes fondling my MacBook and talking about Microsoft. Go figure. Right? So this kind of, I got this on Friday. I'm still learning how to use it. But this is what has inspired this, okay? So like Zev said, I've been coding for about 30 years. The last 20 years have just been, I've always been on Windows, always. Last 20 years I've been only coding for Windows stuff because I've been coding in .NET and Microsoft everything. Microsoft has always been seen as like, you know, the big bad wolf of the software scene of everything. And everything that they did was driven towards selling Microsoft servers, right? I even used to always say that. By the way, I should say, unlike Bradley, I don't work for Microsoft. Bradley has an awesome job. I would work for Microsoft maybe if I had a job like Bradley's. But I don't work for Microsoft, so I don't want you to think that that sways anything. They don't pay me to do that. So they've always been seen as this big bad wolf. But Microsoft has changed enormously. And I actually wanted to talk tonight, really because I was so excited about, like, I actually am coding on OS X now. But what, I can't show you the coding I'm doing because it's just not enough time. So I do want to make sure you understand, because I think a lot of people don't realize that Microsoft, like IBM, right? Bradley's doing all that open source stuff, lots of stuff on GitHub. Microsoft has actually totally finally embraced open source in a really big way. So their new main core API for development, the .NET development environment, is on GitHub now, along with the most, like, ASP.NET 5 is their big thing also. Microsoft, these are just, you know, their GitHub accounts, okay? So in addition to that, the other big thing is the new stuff that they're working on is going to be cross-platform, right? So running on OS X, Windows. It'll still run on Windows, but also on OS X and on Linux. And so even though Microsoft's got this new great Surface Book that they want everybody to buy, and they assume that all the .NET programmers are going to go out and get them, because of all the stuff they're doing with open source, not just open source, but cross-platform now, we're all like, oh my God, do you mean we can, like, work on Macs. Like, I don't have Windows installed on here. I'm going to have to. I got Parallels. I don't even have Windows installed on here. So there's a lot of people like me who are going out and like finally getting to buy our first Mac and play with it and learn how to use it. So what's going on with .NET is that in addition to the .NET framework, which has always been something that relied on Windows, it was actually part of Windows, it got installed in Windows, it is this behemoth of a thing. Okay, so in addition to that, they have now this whole, right underneath everything is the .NET Core, and the .NET Core is what can work on these different environments. So it's a runtime and a development environment. So it not only allows you people to build, like, I could still just focus on Windows and be coding in Windows, but I could create stuff as long as I just limit what I'm doing to that .NET Core. I could create stuff that could run on these other OSs. I could take, it has a Kestrel server, which is based on libviv, so that's also going to be able to run on, that runs on Unix and OS X also, so you can like take the stuff and put it on a Docker container and put it up on the cloud and just deploy it. So I could start from there, or if it's somebody who wants to be able to create cross-platform stuff and is developing, you're somebody who uses OS X or Linux, you could start there also. So they've got all of this now, and it's also all, along with being on GitHub, and along with it being cross-platform and open source, it's also all deployed on NuGet. So it's, instead of these huge things, it's just all these small packages. You go to Microsoft now, and they're all like talking about grunt and gulp and yo and this and that, and it's like this whole new language, especially for me because I was never, I'm not a front-end developer, I'm not like a JavaScript developer, so that's all new. But it has changed. The other thing, this happened 2 days ago. This is probably the most popular Windows blogging engine that there is, and Microsoft created a bunch of years ago, but just stopped working on it, and they actually just made it open source also. So that is it's not even owned by Microsoft. It's totally open source. And within this, I took this morning, within 2 days, there was already 194 forks. So I'm sure there's going to be like an Electron version, and somebody's probably going to create one in ASP.NET 5, so it can also be part of that DNX runtime. Also, just the other things they're doing that aren't just all Microsoft. If you go on Azure, you can create like an Ubuntu VM, right? Or you can do all kinds of stuff. So they've been deploying all of those and integrating with a lot of people. But what I'm most excited about, and what I wish, if this was a 10-minute demo, I would have just 10-minute time, I would have just demoed this and not talked about all the other stuff, is that they've taken the IDE that we've been using. We've been very, very fortunate as Windows developers because we've had Visual Studio for years. I know that Eclipse is like really awesome now. I opened it up and it looks exactly like Visual Studio. I wonder how that happened. But Visual Studio has always been an incredible development environment and for debugging and everything. And now what they've done is they've created a version of Visual Studio. They've created it in Electron. So it runs, I'm like using it now on OS X. So the Visual Studio, it's just called Visual Studio Code. So it runs on Windows, Linux, and OS X. It's like, any Sublime Text or, whatever text editor you might use. It has, support for all the languages and coloring and all that kind of stuff. You can develop with ASP.NET 5, which is that new kind of DNX.NET Core stuff, and also you can develop nodes. So I haven't even done ASP.NET, .NET development in Visual Studio Code yet. I actually never did JavaScript, and now I've just created an application. I've done all this Node. I created a Node Web API. I used Aurelia for the front end. And then I used DocumentDB as on the cloud as a server. So I'm doing all that. So, and this is possible because Visual Studio Code is written in Electron. So Microsoft wrote it in Electron. It's deployed with Squirrel. So there's Squirrel for all the different operating systems. It's completely open source on GitHub. And this last little thing over here is kind of representing their gallery. because it's open source, there's already tons and tons of extensions. Some are Windows kind of extensions, and some are just generic extensions. So I've been programming for 30 years, and I'm still having fun because of stuff like this, right? So instead of me having to totally switch and drop everything I knew, it gave me this incredible transition. And now I have a new toy, and I get to be like all the cool kids now. Next victim.
All right, so Shane Celis is an evolutionary robotics researcher turned video game developer. He makes fun virtual robot toys that hint at artificial evolution.
Hi, my name is Shane Celis. Thank you all for coming. Thank you for inviting me. So my talk is called The Magic of Fiction. And just a little bit about me. I'm an independent game developer. I also run the Vermont Game Developers Group. We get together once a month, have a talk and a few show and tells. I mean, I actually do 2 stories in applied fiction, which is dangerous for a 5-minute talk, but I timed it, it should be fine. One's in academia, the other one's in the kind of technical game development world. Before this, I was in academia. I worked with Josh Bongard, who's like one of the smartest, nicest guys you'll ever meet and hope to work with. I also worked with Peter Dodds, and I worked as a grader for one of Peter Dodds' classes. And if you've never done grading, it's not great. It's mind-numbing, it's time-consuming, and it's mundane. So it's not an exciting thing. Peter did something really interesting. Instead of being a grader, I was a secret Department of Truth bureaucrat. And I don't know how he got this, he set this up. So I'd write these like emails in this kind of perfunctory, stilted kind of style. And I was secret. So all these things were redacted. Like my name was redacted, the university was redacted, the department was redacted. And it took something, and really this was kind of easy to do, right? All I'm doing is I'm substituting like a functional name for a fictional name, but it added like so much to the experience. It was whimsical instead of mundane. It was clever instead of mind-numbing, and it also had me do the work better because like there was material possibly that when I was grading that I could like plug back in. And one of the reasons that I think this is noteworthy is because in academia and in technical work, I found that work really kind of eroded my inclination to try to use fiction in this way, right? Because like it's not a respectable thing to do in an academic publication, but it's so useful in so many other ways. So it takes me to second story. This is in game development, and let's go right into the tech demo. So let's see. All right, here we go. Okay, so this is a tech demo that I made shortly after coming back from my honeymoon, where we went to the Wizarding World of Harry Potter. This is a leap motion substitute wand detector. This is a stick, pencil, or chopstick substitute a wand. And in here, we've got not a unistroke gesture recognizer, but we've just got magic. So these are the first substitutions we're making. So you can see it's reading the tip of my wand, and now let's try to do some spells. All right, so we'll do Silentium. But we want to be able to do spells on something, so let's try to turn on the light. Lucerna. And let's add some color. Manifesto. And so I can reach out and poke things in here. This thing is actually kind of messed up, so let's fix it. It's the Tua. And maybe we'll make them dance. Oh, there we go. And we'll have them jump. All right. So there are other spells. This is a quick thing. So this was the tech demo. I was really happy about this. I was like, oh, this is great. We had Maker Faire coming up, and we were trying to think of, my wife and I were trying to think of how do we change this into something that's not just a tech demo, but an experience. And we put together this booth, and one of the ideas that I thought was really took it to a different level that I would have never thought of. That credit goes to my wife Nakia here. Is she split up wands into these 4 different jars, and she labeled them all differently. And we had kids pick, and these were just chopsticks. They were all the same. So this is not even a functional name, right? These are functionally the same. But we gave them all different imaginary names. There was Hair of Minotaur, Eyelash of Cyclops, Scale of Mermaid, and Toenail of Lake Monster. And which was amazingly popular, that I did not expect. And it really enriched the whole experience. And so my takeaway from this is if you can, if you're at liberty, add some fiction to your project. And it's not that hard to do. Pick a theme and use simple substitutions. And that's it. Have fun. All right. Thank you.
So Sara Simon is Vermont Public Radio's web developer. She has impeccable grammar and amazing emoji skills as a result of several diverse degrees.
I really like that last talk. I was an English major, so yay fiction, but now I work in news, so you probably don't want me to make things up. Hi, my name is Sara. I work at VPR, as I've said. We are in the middle of a membership drive right now, so I'd be remiss if I did not say that your gift makes a difference. Okay, I'm talking about bots today. We have 3 different Twitter bots at VPR, and I'll talk a little bit about them. Bot number 1 is our archive bot. So VPR's archive is called VP Archive. Which makes me laugh every time. But basically, this was totally selfish. I moved to Vermont not knowing anybody, not knowing anything about Vermont. And I started this job at VPR, and I wanted to learn a little bit about, okay, they've been around for a while, they've reported a ton of different stories. Without sitting down and actually digging through the archive, how can I get these stories coming to me, maybe once a day, twice a day? I also really wanted to build a Twitter bot. So I built this bot. It's just a really simple Python script that's connected half to the NPR API, which gives us all of our stories from the past few years, and then beyond that we have our external database, which is online in a remote place. And so the other half of it just goes and scrapes for a different story. So it runs twice a day, once in the morning and once at night. And it gives me a story, 2 stories a day to learn a little bit about the past of VPR. On Thursdays, it adds a hashtag. The second Twitter bot is our sewage bot. You might have heard about this. It got some coverage this past summer. In the newsroom, we lovingly refer to it as the poop bot. But basically, anytime there's a sewage spill in the state of Vermont, the state is required to report it. And the state is required to report it to this website that's way off, tucked away in the tiny little corner of the internet that's very hard to access and hard to get to and hard to read. And so we figured, what if we could watch that website? And so we had a reporter in the newsroom who was literally sitting there refreshing the page anytime it looked like it was raining outside to see if there might be a sewage spill reported. So now, this is what it looks like right now. Turns out the hard part is not writing a simple Python script. It's not writing a beautiful soup script to scrape it. But the hard part, when you're working with a government website, is that it changes all the time. So you can see here there's an authorized wet weather combined sewer overflows table. There's an all other overflows table, which implies that they're not authorized, which is scary. There's a newly reported overflow table. So this is what it looks like today. A few weeks ago, it looked totally different. And also it's tricky because newly reported spills are not always first reported in the newly reported category. And when they are reported, they're reported in this table, but it's not the same table format as the other two tables. So imagine like trying to write a script to scrape the site. It's pretty difficult, and it changes it quite often because they change the site quite often. But anyway, follow the Twitter bot, Dirty Water VT, and you will learn when there are sewage spills reported in the state. Bot number 3 is still in testing. It's our hospital information bot, so it's VT Hospital Info. Similar to the sewage spills, anytime that anytime that a hospital in the state is inspected, that inspection report is required to be posted. It's required to be publicly available. Again, it's tucked away in a far-off corner of the internet that's hard to access and hard to read and hard to get to. So again, we had reporters who were sitting there refreshing the page, waiting to see if the hospital was, had some kind of like major inspection flaw. So here's an example of the site. Each hospital has its own page where there are PDFs just listed. And so basically what the bot should do, we'll see if it actually happens. Next time there's a spill, or next time there's an inspection report, so here's a PDF, and it will tweet the report. So right now, like as you can see, it like tweets, as of November 24th, it would tweet the name of the hospital and that there was an update. I hope next time it happens, the report itself will actually be tweeted, which could make a big difference. Like, so say for this one, for example, it came out October 22nd. We will follow up to verify that substantial compliance has been achieved and maintained. If we find that your facility has failed to achieve or maintain substantial compliance, remedies may be imposed. If I'm a reporter, like, I'm going to want to follow this story. Most importantly about all of these Twitter bots is that they're all open source. Every line of code I've written for VPR is publicly available on GitHub. Pull requests always appreciated. Thank you.
All right, so Mark Ibrahim enjoys Python, math, and Vim, along with a good cup of coffee. He and I run the Python meetup, the Python user group. Before moving to Burlington to study math, he worked in market risk management for UBS.
Okay. I'm going to talk to you about Wikipedia, something I've been studying for about a year. And mostly, so Wikipedia is a place where we go for information. The biggest store of information we've ever amassed as human beings. No joke. So it's pretty much where you go if you want to look up your local officials' office, some quirky fact about Burlington, but also for kind of global trends.
It's nice.
Yeah, does that work? All right, cool. And so what I've been studying is Wikipedia not just as a place where we have information, but Wikipedia is a place that connects ideas. So the whole premise here is that if you go to a Wikipedia page, let's go to one. Ooh, hold on, this was the grand slide. So let's go to the page for train. A lot of text and information, but there's also a key part of this article, and it's a link. If you read the article, there's a link that goes to another Wikipedia article. So the whole idea here is to build a network that takes one article and connects it to another. Let's go back. And that's what I've been doing for the past year or so. You look at a network where each node is an article that expresses information, and then edges are links that connect that idea, expressed in the article, to another. All right, that took you to training. So what we did was actually go through and parse every article on Wikipedia, and we looked through every connection in the network and amounted to something like 232 million chains of links, and we mapped it as a directed network. So our goal is to see what ideas look like based on how we organize them and how we relate them. So some of the things that we measured were the number of links. So how many links or how many references this particular idea or article has. Where do links tend to accumulate? So do they flow through the network and then build up to one idea that we all somehow relate many other things to? And the kicker there is that philosophy turns out to be that place. So if you click on the first link in any article on Wikipedia, and you keep doing it, you'll always end up with philosophy no matter what page you start on. Very bizarre. So you pick chair, computer, banana, beer, click on the first link, and it generalizes. So if you start at banana, the first link is something like fruit. Fruit takes you to something like biology. Biology takes you to science. Science takes you to philosophy. So we've uncovered kind of a flow through the network where we look at both the depth of ideas that connect to one another. We look at things like cycles and basins, which group a bunch of ideas together. And we look at particular articles and how they influence the overall shape of how all the information that we know is organized. So I won't go into detail about some of the findings. Maybe just a big picture summary. And a lot of what's called free scale distributions. So if you look at things like the depth of the network, you look at the number of links that accumulate somewhere, or you look at the influence a particular article has, it turns out it's kind of a 99% story. So 99% have very, very little, and 1% has pretty much everything. We find philosophies at the center. We also find that most ideas tend to flow in the same way that I just described, from a very specific concrete object or topic or event or person or place or invention to broader and broader abstract concepts. So things like philosophy, science, community, state tend to be the anchors where we place all of our ideas. It also turns out there are a few topical things that pop up. So things like healthcare, things like fossil fuel also show up as points of gravitation, where if you start with very specific, ordinary, everyday things that we care about, events, people, inventions, and you look at how those ideas flow and connect to one another, they build up to these things that we hear about in the news and care about. I'll show you a bit more. So there's a whole website where you can explore the results. You can see where links accumulate and so on. So these are all IPython notebooks. These are the top pages and so on. I'll show you some of the groups over here. So these are sized by the amount of accumulation towards those articles. These are groups of 3, and these are the largest ones. So ideas like U.S. Supremacy Clause and Article 6 of the Constitution, or France, the Kingdom of France and medieval France, and so on. And this is scale free distribution, and so on. So you can start with a specific question like, what articles shape the network structure, and actually pin it down to the highest ranking articles and the distribution of influence. How much of that?
Pretty much done.
Okay, good.
All right, so Nick Husher is a front-end developer specializing in user interfaces and a functional programming hipster / advocate. Formerly a dealer, now a senior developer at Faraday.
All right. How many people here work in web applications? Yeah, a lot of you, basically everyone. How many people maintain or work with a single page application, like a rich web app? Yeah, some hands. So Figwheel is a tool for building single-page, rich web applications in JavaScript, but it actually is in ClojureScript. So ClojureScript is one of these new compile-to JavaScript languages built on a functional programming language called Clojure, which is originally built for the JVM. And Figwheel helps you build these applications in a fairly magical way. So let's look at the world we live in as front-end web developers or as application developers generally. So we write code, and then we wait for our code to be compiled or interpreted or whatever we want to do. And then we reload our web app to see our new change, and we lose our application state, meaning that all the work that we have done up to that point goes away unless it's been stored in the database. But very often you have stuff that's staged up, or you were in the middle of a form, maybe a multi-step wizard. So you then fiddle the app to get it back to the state that it was when you started, or to see the thing that you've changed, and then you test your change. And it doesn't work because we're not that smart as humans, so we do it again. And then we do it again, and we do it a little bit more, and we do it a little bit more. So what's the alternative? I would rather write code and then see that change instantly. Like, I want to write the code, and I want to see it happen in my in my web browser instantaneously and not lose my application state. I don't want to go through and come up with a new name and a new address, or try to come up with some good fake data to put into the system to really test its limits. I want to do that once and do it and not have to do it again and again, because that means that I check out. I don't test my application as firmly as I should, as completely as I should. So Figwheel, coming back to that, it detects changes in your ClojureScript code. It compiles that code down into JavaScript. It will then inject your code into your running application, and then and it shows the change instantaneously. And then it also allows you to access the application state of your browser application with a REPL, so you can actually change the behavior of the running application. So why is this important? Like, well, when we think about writing software, this is kind of the way that we might want to think about it, where we have a starting point and we have a goal, and we want to go straight from one to the other. But what we really have is I screwed up the slide. What we really have is sometimes there's some mistakes that happen. And hold on, let me fix this. I'm gonna build it. Okay. All right. We'll get there.
Is that like a demonstration?
No, but and fix everything. Hold on. Let's start Figwheel. So we're going to start the auto builder, and then we're going to change this. And did you see that? Did you see it just moved? Yeah. So that's the value. I can make changes and see the change happens. And so when we're moving through this space, we have a lot of dead ends. Like and when you plan too much up front, you miss value that you might have found along the way. You might be able to implement something much more simply, or fix some things that you didn't know were broken. And so then you finally get to your goal. And so this is a way of writing applications that needs to be the way that we do write applications. So that sort of represents the value present in Figwheel. And that's, I would highly recommend you try it out. Clojure is a really great language. It's really easy to get started if you're familiar with JavaScript or familiar with functional programming generally. Or if you're a Lisp hacker. Some people I know out here are. So that's all I got.
Eric Smith is Senior Vice President of Product Development at Middlebury Interactive Languages. Eric agrees with L. Peter Deutsch that to iterate is human, to recurse divine.
Where's my...
oh, sorry. Yeah.
I need the...
Sorry.
Cool. So I'm lucky that was right before my talk. I'm just going to show you a simple trick. Especially if you're, this is from the trenches. If you're in a business that's trying to grow, this may be useful. Everybody else, you might not care. As you said, I'm Eric Smith. I work here. We do language learning for kindergarten through 12th grade. First, public service announcement. I'm involved with VT Fund, which is the Vermont Functional Programmers Group. And next Friday, we're having a guest speaker from the University of Washington, PhD student there, is giving a talk on using the dependently typed language, COC, to make sure that a distributed system does what it's supposed to. And even if you think that this might be over your head, it may be worth your while to come and let it wash over you. We're certainly happy to have people. Yep. I don't know why. There we go. And if you're interested in my worldview at all, I was recently interviewed at functionalgeekery.com, so I don't have to give you my usual spiel tonight. You can get it there. So I'm going to talk, as I say, about a way of serving web applications. It's a simple trick. For 20 years, the way in which applications were built on the web was basically the same. There are users over on the left. Port 80 is what, by default, at least on Linux and Unix, web servers listen to for that traffic coming in. And then you have, whatever your application technology is, and it's backed by some sort of database. I picked 2010 because that's about the time that microservices started to come on the radar. Rails finally had a reasonable deployment story around that time, and what else? Oh, and Clojure and Scala were just really getting a foothold as industrial languages, as two of the new breed in languages. And so here's the trick. It's something called a reverse proxy. Basically what the idea is that rather than having your application web server listen to port 80, you put another web server, in this case it's Nginx, listening at port 80, and then what it's going to do is it's going to send that traffic back to something else listening at a different port. And so you can see the graph has become more complicated, but your old application is at some new port, and then you're able to bring basically a new stack, a new generation here at a different port. And then so if you have /something, it'll send those to different ports. It can have its own database. It can go see something else in the world. It can even connect to your old application stack and connect directly to that database as well. And I'm not making this up. I've used it a couple of times, and it's really quite helpful. So why would you want to do this? The primary reason, certainly for me, is that you would like to move to a better language, a functional language, as opposed to a non-functional language. It also helps you avoid cross-domain issues. So if you're in the browser and you're trying to hit a different subdomain, the browser is often not going to tolerate that without some gyrations from you. This trick gives you an easy way to fool the browser into thinking that some other service or API is at the same place that it got the initial request. You can use this trick to do a cutover where the web server will actually, you'll switch from one port to another port, and whichever one is listening will get picked up. Microservices, this is the way in which you can incrementally add them on. This is also a way to map out CQRS, which is command query responsibility segregation. For instance, if you have databases, you have data where you have a lot more reads against that data than you have writes, you can split out your application stack to handle those appropriately rather than using the same resource-intensive single monolithic application to handle that. And somewhat related to that, you can start to store data as NoSQL or just some alternate rather than that relational database you had behind your old application stack. And also, you can use this kind of thing for caching and logic behind caching. I have Varnish here. Varnish is a little bit different than a web server, but it has a kind of a similar function. So I just wanted to make you aware of that. And here's kind of what it looks like. In Nginx, this is the configuration, somewhat redacted. But down here at the where it says rewrites / monitor, that's actually the URL segment that's going to get requested, and it's actually going to get passed to a port. That's what this proxy pass and then an environment variable. This is complicated. This I pulled directly off of Heroku, so it's a little gnarlier than it usually looks. This is another one where down here at the bottom you have two locations. One is just the root location, and the one above that is /data, whatever, and they will actually go to two different things, which are up here at the top. So app cluster and pub content are multiple IPs with different port numbers, and then these different parts of the URL segment will go off to those things. And this, lastly, is what it looks like in Apache. So here where it says proxy path /data, blah, blah, blah. It's some, in this case, it's just the local machine, but it's some port number. And to get the traffic back in Apache, you have to do proxy pass reverse. And the notable thing is this / at the end. And that's pretty much my trick. And I will finish up with another public service announcement.
Alright, so those are the lightning talks. Please stick around, have pizza, beer, seltzer, talk to each other, talk to me. Hopefully we'll do another one of these maybe next month or next quarter. I'll probably send all of you a poll about that like next week. So, thanks.